Welcome everybody. In today's video, we'll look at the presentation of all real numbers on a straight line. And please recall the meaning of real number from the previous video. And it basically contains all the rational and irrational numbers. So how to present the numbers in a systematical way on a straight line here. So the way to do it, you have to write down the numbers just as the marking on a ruler, from the smallest to the biggest, from the leftmost to the rightmost, the smaller number on the left side, the bigger number on the right side. For example, the middle number definitely is the 0, is the unique number in the middle, and then you can do the markings on the right side for the positive integers. For example, the next one is 1, 2, 3, and so on. So the markings, please remind yourself that it's really just like ruler, which means the distance between 0 and 1 and 1 and 2 should be the same. And okay, so on the left side, you can do the negative numbers, the negative markings, -1, -2, -3, and so on. So now I claim that all numbers, all real numbers, can be found on this straight line. How? Definitely now all the positive, negative integers are easily seen here. So all these numbers are just the markings on the whole straight line here. How about some decimal numbers? For example, 0.5. Where is this number? This number must be exactly in the middle between 0 and 1. So in this case, for example, how to find the number square root of 2? Square root of 2 is something like 1.414, etc., which is a non-repeating decimal, and this number should be somewhere here. So you should be able to find it out anyway. So anyway, now it basically means that all rational numbers, all irrational numbers can be found on this straight line. The second thing of today, actually, if you look at the real number line, the interesting fact is that the algebraic operations, for example, both additions and subtractions, can be found in a geometrical way using the real number line. How to do it? Just give you a simple example here. If I'm looking at the following, -2 plus 3 here, so you can interpret this addition as, you look at the first point, -2 first. Now addition basically means you are moving to the right side by 3 steps. So please look at this 3 as the number of steps I look at for the movement to the right. So you move yourself 3 steps, 1, 2, 3. So now we arrive at this new point, and this point must be the answer to this problem. So the answer must be 1. Definitely for this simple example, you can just do it by calculator, but I believe it's just an interesting way to look at the addition by moving the steps around. And similarly for subtraction, if I'm looking at 3 minus 4, again we start from the first point, which is 3 here. We are in the location number 3 here. And minus now basically means that you are moving yourself to the left by 4 steps. So this number represents the number of steps you need to move to the left side. So let's do it. 1, 2, 3, 4. So now we arrive at the new point, which is the location -1. It basically implies that the answer to this subtraction 3 minus 4 is answer -1. So that's the way it is. The next thing here is that the meaning of negative number has a very interesting interpretation here. For example, if you look at the number, let's say 2, if you're adding a negative sign in front, this adding negative sign in front, this kind of process is the same as originally you look at the point 2, and adding a negative sign is the same as a reflection process around the mirror, which is 0 as a mirror. It's a reflection process. After reflection, you'll get a new point -2 by using this 0 as the mirror here, and which means that taking a negative number is the same as a reflection process on a real line. So why is it interesting? You can look at the following example. Let's say if you take a number 3, we are originally at this point, at this moment. If you add a minus sign, it means that you are reflecting around this mirror to get a point -3 here. That's my meaning of this point. Okay, If you think of adding a negative sign as a reflection process, how about add the negative sign again? So negative 3, it means that we are from this point negative 3, we do a reflection again and get back to this point again. It's a reflection process around this mirror. So now it means that this number negative 3 must be the same as number 3, because we are doing reflection 2 times, we get back to the original position. And please note that it is actually a common property of negative number that if you have any number x, you take a negative x and take a negative again, you get back to the original x. That's a common property of negative numbers. Now it can be interestingly interpreted as a reflection process on a real number line. So one last thing of today, we can talk about the size of the number. If I say a number A is bigger than number B, we can use the inequality sign to represent that. And then to interpret it on the real line, it basically means that the number A must be in a position that is on the right side of B. That's the meaning of A bigger than B. And similarly, if you talk about the meaning of A is smaller than B here, A is smaller than B, we have this inequality notation. Then it means that the location of A must be on the left side of B. So I think in terms of the real line, the meaning of bigger and smaller is pretty obvious here. Okay, so we talked about a couple of interesting properties of the real line here, and that's the end of today's class. Thank you, everybody.